When we're working with structures in C++, we can make them even more versatile by nesting structures within other structures. Let's take a look at the program we did in the last video, which was just structures with functions. And let's take our student record structure that we had, and let's add to that the birth date of a student. So we can put that in anywhere. It really doesn't matter where we put them, but let's put it in here after the first name and the last name. So I want to put something in here that would be the birth date. Now, I could do that by putting in three simple elements to this, three member elements, which could just be the month, the day, and the year. But it's very common to use something like that, a date with month, day, and year. It's very common to use that in a lot of applications. So we can make a structure that is just for the date itself. So let's write that code and let's put it in here, and we'll make a small structure just for the date. So we'd start with the same reserved word, struct, and I will call this date because it represents a date. Then, inside our curly braces, I'm just going to have three unsigned integers, which represent the month, the day, and the year. Now, I like to write my structures like this, but you don't have to put them on three separate lines. I could have just used unsigned integer month, comma, day, comma, year, and it would give me the same thing. I just happen to like the way that this looks better than putting it all in one line. Now, once you have declared a structure, you can use it in another structure. You just have to make sure it's declared before it's used. So in here, I am going to add the student birth date. So I'm just going to take a line and I'm going to put it in here, and it's going to be type date. Okay, so date is the type, and that's because we have a type date declared right there. It's a structure, and the variable is going to be called birth date. So now I have what's called a hierarchical structure. So this structure, the student record structure, it contains yet another structure. So this is known as hierarchical structures, and you can have as many of them as you want. You can keep nesting them inside each other as long as you can tolerate all the dots that you're going to have to use. Now, given that I've kind of said, hey, we're going to need multiple dots here, let's see how we can enter data for the birth date for students. So I'm going to still use this the same example. So we have the functions already to enter data. And the last iteration that we did with this program, we had a call by reference to do that. And that's fine. It doesn't matter how I call it, if it's by value or if it's by reference. So let's go ahead and let's modify now the enter data function so that we can enter the birth date. How do we do that? Now, again, it doesn't matter in what order we do these things. I could put it at the very end down here, but it just kind of makes sense as far as the flow is concerned to put it after the first name and the last name. So we type in, what's your first name, what's your last name, what's your birth date. It just kind of makes the flow better to go in right here. All right, so that's where I want to do some modifications to my enter data function. So let's add the prompt, our cout statement. And this says to enter the birth date as month, day, and year. So we need to come in the correct order. Then we're going to read those in. So we'll have the cin statement like we did here. But now how do we accommodate the extra layer of structures that we have? Well, we have to use an additional dot to do that. So let's put the cin statement here, and let's look at how this works. We need to get to the birth date field within the student structure, or that student record structure, which is represented by the formal parameter student inside the function. So the birth date itself has three fields. It has the month, and it has the day, and it has the year. So if we want to access those individual fields, we use an additional dot. Okay, so to get to the birth date, to get to that part of the structure, we use one dot, student record dot birth date, or Alice dot birth date, or Bob dot birth date. Then to get to the month and the day and the year, we use an additional dot and we specify which of those three fields we want, month or the day or the year. So it turns out to be a pretty simple way to do it. So you can nest structures within structures, but then when you do that, in order to access those individual fields, those individual members of that function, of that structure, then you have to use an additional dot to do that. So this allows us then to input the birth date for the student. So now we can get that information into our data record. Since we have this new information, we want to print that out as well. So we need to modify, the compute grade function, we don't deal with the birth date in that function, so we don't need to change it. But we do want to print out in our print record function, we do want to print out the birth date now. So let's add the cout statements for that. So I'm going to paste that in here. And we use the double dot notation in the same way that we did up above here. So I'm going to make this, let me modify this a little bit, and we'll put this on 3 separate lines. Try to anyway. There we go. So this cout statement will print out the student's birth date dot month, so that prints out whatever the month is. Then we will have a set width of 3 here, and we'll print out the day. Then after that, we'll do a set width of 5, and we'll print out the year. So this will print out the birth date of the student. So that will come out here. All right. Now, I suppose we could go ahead, and we've got these identifiers down here. So we could add that in as well. We could print out the birth date as the string, and then print out the other information. So let's add that in as well. So let's just put that right here. I'll just paste that in. So we'll print out the birth date as a string, and then the actual birth date itself. That's all we need to do. So you can then set up these hierarchical records, and they tend to be very handy because there are a lot of things that you would repeat. And I'll show you some examples coming up. So the date of the year is very commonly used. We could do the same thing with time, hours, minutes, and seconds. Location, like altitude, latitude, longitude, altitude. So there are a lot of things that we can set up as structures, and we can use those by embedding them inside other structures like we do here. Now, let's run the program, and we will enter the information for the birth date this time. The program's running, so let's bring this over. Now, I've already typed in the first name and last name for Alice, and notice we're being prompted now to enter the birth date. So we will just type in the birth date. Let's make up something here. So let's say it's June the 15th of 1999, and we'll type that in. And then we proceed to type in the other stuff, like the same thing you've seen already, exam, score, and the homework, average. Okay, and then we compute the grade, we print that out. Now, with the modifications to printing out the data record for Alice, we see here's the data record, then I've added in the birth date. So now the print data function prints out the birth date as well as all the other information. So that comes out here. Okay, so we could do the same thing for Bob. So we could type in Bob's information, and I guess we can do that. And here's his birth date. Okay, so let's suppose that his birth date is going to be April the 12th of 2000. Okay, so we type in the rest of his information, 3.5, exam 85, okay, homework 92, and then we output his information. So here we have the data record for Bob, and now we show his birth date as well. So that then illustrates how you can nest a structure inside another structure. And the key thing to remember is when you're accessing those individual elements, then you do have to drill down by putting in additional dots to get to each of the elements, the member elements of that nested structure. Like in this case there we have the date is the type that we use for birth date. So we have to use 2 dots to get down to that. And we do that for the enter data function, and we do that when we want to print out the information as well. All right, so it's a pretty simple procedure. Just have to remember the dots. Now, what I want to do to finish up this video is I want to just bring in another program, and all it does is to illustrate some different things that we can declare as structures. So I brought in this other program, and there isn't much to it except some definitions for structures. So here's the one that we just used, date. And in this example, I've shown you that you can just put all three of the member elements on the same line here. That's the same as having three unsigned integers for month, day, and the year. And don't forget to close that with a semicolon each time. Okay, here's another structure, and I'm calling it my time. The reason I'm not calling it time is because there's something already in C++ called time, which is a function that returns the time of day, so I don't want to interfere with that. So I'm calling this structure my time, and it just has, again, three elements, which would be the hours and the minutes and the seconds. So that's a common structure that you might want to use in various applications. Here's one for name, full name. Okay, so we could have the first name and last name. That could be type string, and we could put the initial if you wanted the full name to represent the first name, initial, last name, then we could put an initial in here. All right, so that's another example. Of course, if you wanted the full name, you could make a string, first name, middle name, last name. All right, so that's just another simple structure. Another common one is the street address. So here is an example of that, and I'm just using three strings this time. Okay, we have a string for the street, and a string for the city, a string for the state. Okay, now you might also want to put like a house number or something like that in here, a street address, which is the name of the street plus the number, things like that. So you can set these up any way that you want. This is just an example then, which is a common thing that you would be using. The last one, I'm going to incorporate a enumerated type, which is an eye color, brown, blue, green, and hazel. And I'm going to define a structure that could be used for a license, like a driver's license. And I'm going to use some of the structures that I've already declared up above. So I'm going to declare this to be a structure. It's going to be called license, so that's the type that I'm declaring. And inside here, I'm going to have the name. The name is going to be full name. Okay, so that was declared up here. So it's going to have first name, last name, and the initial. Okay, so this is a nested structure, a hierarchical structure. Same thing, DOB, date of birth. That's going to be a type date. That's month, day, and year. Okay, the address, I'm going to have a member called home address inside the structure license, but it's also a hierarchical structure. I'm going to use the type address. So the address, where's the address up here? It had the street and the city and the state. So within the license structure now, I've used several other structures. So this is an example of combining structures to make a more elaborate structure. Okay, then if a license has an expire date on it, so that's going to be a type date, so I'll put that in there. And then I've just got some regular, a couple of regular variables, unsigned integer for the weight. It usually is not a real number. And then we're going to have the height in here. And I made that a string, okay, string. Why would I make the height the string? Well, in most licenses, they use the height in feet and inches, and they use those little extra marks to represent what the feet and the inches are. So that doesn't translate to integers all that well, so that's why I'm making this a string type. And finally, the eye color, that's going to be an enumerated type. So I'm using the enumerated type color here, okay, that's enumerated type, and the member element of the license struct is called eye color. So that's going to be the type of eye color is going to be this enumerated type up there. So here is an instance then where we have this license structure, which is heavily dependent on using these other structs that we've declared up above. It is important that you declare them before you use them, so make sure you declare all of those other structures prior to using them in another structure, as I've done here. Okay, now finally, we still have that student record that's left over from a previous video, so I've just left that alone. The main program, there's nothing in there. I just wanted to be able to compile this to make sure that I didn't have any errors, so I just made a main program. And I declared a variable called driver, which was of type license. Okay, but I didn't go to the trouble of writing functions that would allow me to fill in all of this data that goes with the license structure type. So there'd be quite a few things, quite a few things there that I'd need to type in. And in fact, as you start to get more and more complicated or I guess rich structures, then you might want to have a file where you'd read the data in instead of typing it in from the keyboard. So if we had a file here that had this information, it would be easier just to open the file and to read that data in, and then we didn't have to type it. Or, I guess to create the file, we'd have to type it once, but from then on, we could just open the file and read it in. Okay, so there you have it, and I'm sure that you can think of a lot of other structure types just depending on what area that you're working in, but this is the syntax that you would follow. So the C++ language now has given you a tremendous amount of capability where you can declare this thing called the structure, and you can organize data into that structure which all belong together. So it's kind of like a unit, and these can all be separate types. And you can see already that they can be complex because of this hierarchical arrangement that we have. So this makes it easier to deal with data that is typical of just a real world. So you can organize your data types according to the applications that you are writing your program for. So if you're writing a program that deals with some kind of license database, you'd likely use something like that. And these show up in all kinds of applications. So you can refer to this. Hopefully this will be one example you might want to come back to. So it just shows you a lot of different examples of structures that I've defined here. Now, I think that's going to be it. We will see structures coming up again a lot more in future videos, but I want to stop this one here. So thank you for watching.